B paper from Standard Level AA from May 2023. Okay, so find the coordinates of M. We've got a point -3, 2 and a point 15 minus 8. So point M is going to equal -3 plus 15 over 2 and 2 minus 8 over 2. So essentially you're finding the averages of where the points are, and that gives you the half. So that's 12 over 2, which is 6, and 2 minus 8 is -6 over 2 is -3. So that's that point. And then L is perpendicular and passes through M. Find the gradient of L. So PQ's gradient equals the difference in Y, that's Y2, over the difference in X. Let's make that Y1 and Y and X1. So we'll make that 2 minus -8 over -3 minus 15, which equals 10 over -18, which equals 5 minus 5 over 9. So the negative reciprocal for that means L's gradient equals 9 over 5. And we could even write it as y equals 9 over 5x plus c. So we've got to write down the equation of L. So L would equal y minus -3, so that's my plus 3, equals 9 over 5 of x minus 6. And that is how you do that question. Right, this is a function f of x, and it's 7x plus 7 over 2x minus 4. So find the 0 of fx. So for that, for A, we're going to do if 0 equals 7x plus 7, so the top bit, that means that -7 equals 7x, so x equals -1. B, the vertical asymptote. For the vertical asymptote, we're just going to solve. We're going to, what's the word? Factorize the top and the bottom. So we'd say 7 comes out of that, it's x plus 1. And then on the bottom, it's 2, x minus 2. So our vertical asymptote is going to be 7 over 2. It's going to be that. And then 2, the horizontal asymptote. So to do that, we need 2x minus 4. And we need to work out when it equals 0. And it equals 0 when, I'll just solve it, 2x equals plus 4, so x equals 2. So those are the two. If we did a little graph, when x equals 2, that would be where that, and when y equals 7 over 2, so that's what, 3 and a bit, that's where those would kind of last. Now, f of minus 1x is the inverse function of fx. So we're going to write down, in order to make this its inverse, we're going to write down c, and then we're going to write down y equals 7x plus 7 over 2x minus 4. And we've worked this out. It's when x equals, we swapped it all around. So we go y equals 2x. Let's times out by 2x minus 4. And that equals 7x plus 7. And then let's make that 2xy minus 4y equals 7x plus 7. Now we need to get all our x's on one side and as many of our y's on the other as possible. So let's add 4y to both sides. So that means 2xy equals 7x plus 7 plus 4y. Let's take 7x off both sides. So 2xy minus 7x equals 7 plus 4y. Let's take x out of this. So let's extract x or factorise x out. 2y minus 7 equals 7 plus 4y. And let's just divide through by 2y plus 7. And that will give us our answer. 2y minus 7 even will give us our answer. And that is... now, in order to completely sort of win at this question, we would then rewrite it as f(x minus 1) equals 7 plus 4x over 2x minus 7. Which looks quite like the thing at the beginning, but there we go. Right. Oh, good. It's people writing. So this is some sort of probability problem. On a Monday at an amusement park, a sample of 40 visitors was randomly selected as they were leaving the park. They were asked how many times they had been on a ride called the Dragon. This tells you the answer. Optimum amount seems to be once or twice. It can be assumed that the sample is representative of all visitors in the park the following day. So for the following day, Tuesday, estimate the probability the randomly selected visitor will ride the Dragon. So the chances that they'll ride the Dragon are 16, 29, 31, 34. So I think A1 would be 34 out of 40. And then the second question is the expected number of visitors of times that a visitor will ride the Dragon. So that would be 6 times 0 plus 16 times 1 plus 13 times 2 plus 2 times 3 plus 4 times 3 all over 40, which is... I know you can put this into a calculator, let's just do this. So 26 plus 16 is 42, 48, 60 over 40. So the chances are 3 over 2 or 1.5. Now B, estimate the minimum times. Okay, so 1,000 visitors will attend the amusement park on Tuesday, and the Dragon can carry a maximum of 10 people every time it runs. So estimate the number of times the Dragon must run to satisfy demand. So we're assuming that everybody wants to ride it 1.5 times. So that means that of the 1,000 visitors, they're going to want to ride it 1.5 times. So that's 1,500 potential rides. But you can only fit 10 people on it at a time. It is assuming that everybody gets on when they do it. So it's got to ride 150 or it's got to run 150 times.